Welcome to this explainer. Today, we're going to break down the massive AI breakthroughs of mid-2026 and how they're basically creating a global ripple effect. We are looking at a world that has rapidly, and I mean really rapidly, moved past those simple conversational bots we all got used to. Now, we're living in a landscape of hyper-efficient, autonomous systems that are actively reshaping industry, science, and even international relations. It's a lot, so let's get right into it. Okay, listen to this gripping quote from the 2026 Stanford AI Index. It states, "There is a widening gap between what AI can do and how prepared we are to manage it." This perfectly frames why we absolutely need to understand the shift happening right now. That gap? It's widening precisely because AI capabilities have fundamentally transformed. We're moving from passive assistants that just wait for us to systems that actually think, plan, and act completely on their own. To really give you a sense of the scale here, just take a look at this massive number, $6 billion. That represents just one single target market, telecom automation by Nokia. It totally highlights the astronomical economic stakes of the new agentic AI landscape. I mean, we aren't just talking about a tool that writes a polite email anymore. We're talking about AI systems proactively resolving broadband network issues and drastically reducing physical field visits. The commercial value here is just staggering. So, Section 1, the rise of agentic AI, from chatbots to autonomous actors. We're starting right at the absolute epicenter of this technological leap, moving beyond systems that merely talk to systems that actually do. It's really fascinating how clearly we can separate the generative assistants of the past from the goal-oriented agents being deployed as we speak. While generative AI creates content based on a specific prompt you feed it, like a short-order cook, agentic AI pursues broad, long-term goals. It breaks down complex tasks, interacts with software tools entirely on its own, and executes multi-step actions without needing you to sit there and hold its hand.
Let's walk through how this builds into an actual workflow. There's a very clear progression here. First, the agent receives a high-level goal. Second, it methodically breaks that goal down into manageable, bite-sized tasks. Third, and this is the cool part, it reaches out and uses tools. That could be browsing the web, writing and testing code, or accessing a secure database. And finally, step 4, it executes the action to achieve the desired result.
And hey, we are already seeing the real-world impact of this. Agentic AI is officially out in the wild. Look at Anthropic's Project Deal, where an AI agent successfully bought, sold, and actually negotiated deals on behalf of human employees in their office. Crazy, right? Or ByteDance's ArtClaw, which is actively monetizing this whole new agent craze with a dedicated subscription model. And in the massive corporate space, ServiceNow is deploying new autonomous AI agents directly into complex enterprise workflows. But hold on a second. It isn't completely smooth sailing. There's a crucial point here. We still face major trust and alignment hurdles. Research from Microsoft, using their social reasoning bench, reveals a stark warning. It turns out these agents execute tasks very competently, but they fail to consistently optimize for the user's best interests. They might get the job done, sure, but not necessarily in the safest or most beneficial way for the human who asked for it. So trust remains a massive, massive question mark. Which brings us to Section 2, efficient multimodal AI models, doing more with less. As these agents become wildly more complex in what they can do, the models powering them are, paradoxically, becoming leaner and vastly more efficient. Instead of relying purely on massive, power-hungry server farms, which, let's be honest, was the legacy approach, the industry is fiercely pivoting. The new efficient models utilize a lean architecture that allows for rapid edge device inference. What does that actually mean? It means powerful AI doesn't just live in some distant humming data center anymore. It can run locally, swiftly, and with significantly less computing power. Just look at this breakdown of the absolute newest models. DeepSeek V4 is managing an incredibly efficient million-token context. Basically, imagine an enormous photographic short-term memory, allowing autonomous agents to process vast amounts of background information instantly. Then you have Mini CPM o4.5, packing incredible real-time interaction across text, audio, and video into just an 8 billion parameter frame. And NVIDIA's Nemrotone 3 Nano, it uses low-bit quantization, meaning it requires drastically less memory to maintain high performance, even when your computing power is strictly limited. And the applications of this crazy efficiency are immediate and highly multimodal. We're seeing tools like Meta's SAM 3.1 dramatically reducing the latency for real-time video detection and tracking. Sandivideo is doing incredibly fast, high-resolution video generation using highly streamlined architectures like linear transformers. And Google DeepMind's Gemini Audio allows you to talk, create, and control audio completely seamlessly. By cutting down that processing time, complex tasks that used to take minutes or hours now feel instantaneous. Moving right along to Section 3, AI accelerates scientific discovery, breaking the innovation bottleneck. Okay, let's look at what happens when you point these highly efficient, agentic systems at the hardest problems in the universe. Take a second to comprehend this staggering number. 10 to the 54th power. That is a 1 followed by 54 zeros. This is the computing speedup achieved by China's Zhuxing 4 quantum computer over traditional supercomputers. When you unlock a new scale of computational power like that, and then you pair it directly with agentic AI, you completely, fundamentally alter the timeline for scientific breakthroughs. This immense computational power is triggering breakthroughs across totally diverse fields right now. AI is officially an engine for core scientific discovery. DeepMind's WeatherNext is providing incredibly fast and accurate extreme weather forecasting. Microsoft's MatterSim is running advanced multitask material science simulations. Meta's open-source DinnoV2 is actually accelerating cancer treatment discovery, and AlphaGenome is decoding genetics to pinpoint rare diseases. AI is effectively acting as the ultimate autonomous research assistant for the world's top scientists. The 2026 Stanford AI Index absolutely confirms this massive shift, particularly noting a sharp increase in AI adoption for clinical documentation, medical imaging, and even diagnostic reasoning. But, and this is a big but, while the efficiency gains are totally undeniable, the index wisely cautions that this rapt integration also expands the attack surface for public health. Rigorous evaluation is absolutely required before we just hand over complex medical reasoning to autonomous systems. All of these immense technological and scientific capabilities naturally lead to our final ripple, covered in Section 4, the geopolitics of AI, the race for global control. Because, let's face it, whoever commands this technology commands a massive global advantage. Tracking the rapid-fire diplomacy over just a few months shows you exactly how fast this is moving. In December 2025, China's open-weight AI ecosystem suddenly surged with diverse models. By March 2026, they updated their rules governing outbound data transfers. And all of this culminated in May 2026 with an unprecedented Xi-Trump summit in Beijing, specifically aimed at addressing AI guardrails and technological trade. The speed of diplomatic movement is literally matching the speed of the technology itself. Looking at the broader geopolitical landscape, we observe a pretty stark contrast in strategic approaches. The United States is focusing heavily on strict chip export controls, such as keeping a tight lid on NVIDIA's H200 and evaluating the safety of frontier models. On the other side, China is rapidly building a sovereign national computing power network and drafting comprehensive new AI laws. Both superpowers are maneuvering incredibly carefully to secure their technological sovereignty without tripping an alarm. These differing strategies are clearly reflected in the cultural divide highlighted by the Stanford AI Index. If you look at the metrics, public excitement for AI is significantly higher in China than it is in the United States. Furthermore, while the U.S. operates under a patchwork of different regulations across states and agencies, China is taking a top-down approach with comprehensive national legislation. It just shows two completely different environments for AI adoption. But hey, it's not just a two-nation race. The whole world is mobilizing to protect their interests here. The UK is actively utilizing NVIDIA's Nemrtron to bring sovereign AI to regional Celtic languages, protecting their culture. The European Union is grappling with what they're calling an AI paradox, basically spending a ton of money on AI but struggling to translate that into tangible enterprise impact. And the United Nations has officially stepped in, forming the first global AI scientific panel alongside top LS researchers to assess the global societal impact. So what's the crucial takeaway for businesses and nations alike? It's summarized perfectly in this McKinsey quote. When everyone has access to the same AI models, the winners are those who use them to build advantages that competitors can't copy. The base models, they're becoming a commodity. The true power now lies entirely in how effectively you can apply these agentic systems to solve your own unique problems. Throughout this explainer, we've really seen how AI is fundamentally changing. It is officially transitioning from an isolated generative tool that you simply chat with into an autonomous global workflow infrastructure. Honestly, it's the new operating system powering enterprise automation, accelerating massive scientific breakthroughs, and driving international diplomacy.
Which leaves us with this final, somewhat provocative thought to take away today. As we unleash these hyper-efficient autonomous agents into the world, agents that are fully capable of negotiating deals, discovering medicines, and running entire networks, who is truly in control? Are we managing the technology, or is the technology beginning to manage us? Thank you so much for joining me for this explainer, and keep exploring the systems that are building our future.